going to move slightly to the west from Houston. And if you think your city is old, welcome to Phoenix, Arizona. A city that feels like it was born yesterday. I'm not from Texas either, something about the right height. Okay, this is a project that we've entitled Repurposed Political Ply. And it's an outdoor shade structure for a number of different events in and around Phoenix and other locations. Its primary sort of existence really depends upon the reuse of political campaign boards, which is predominantly forms the roof canopy. It also incorporates the use of glulam reused dimensional lumber in the legs, and also an evaporative cooling zone that's created by repurposed Voss bottles. But before I get into really describing how this the fabrication methods act in a kind of sort of a transformative way to produce this structure, I just wanted to introduce you very briefly to Republican Arizona politics as a major motivator for this project. In recycling of this political ply, recycling of the actual material, there was also a kind of a corollary recycling, and that is the recycling of political imagery and portrait photography. This is Fulton Brock. Fulton Brock is here as the second term incumbent county supervisor for Maricopa County in Arizona, Phoenix, Arizona. That is the fastest growing county in America last year. Fulton campaigning for a third term, and he was successful in his campaign. So he's now the county supervisor for Maricopa County. Really what interests me about this project is in the recycling of iconic political photography, what happens to those aspirational values that are accorded with political portraits, the kind of things that Roland Barthes described in mythologies. Fulton Brock is the embodiment of a whole set of values that are translated through the photograph. He's a healthy person, he's clean, he's wealthy, he's approachable, and he's trustworthy. And all that can almost be attributed to the grin, perhaps, one of the things. He has a family, a wife and 3 daughters, 4 women that look remarkably similar to one another. But they all have really this ubiquitous smile, which really that translates as a smile of American politics, of trustworthiness. What I thought about this material, when I looked at it and described it, I could describe it in a number of ways. And the material, this plastic material, was cheap, artificial, and disposable. And I realized that description would translate directly also to the people and the politics. Or not to the people directly, but to the way in which their images are manifest and replayed. So what one can't avoid, of course, is the way that this grin changes in the hands of students here, a sense of appropriation in the fabrication process already underway, and how that smile gets compromised, somewhat. I have people to thank partly for this, and I'd like to thank Shin, who came out and he played a role in the early part of it, and then he disappeared into Arizona on a Harley Davidson. So that's Shin just about to part company and disappear over the horizon. But he was also partly responsible, helped form this project. Anyway, back to the core of the project, really. Excuse me, dribbling. In that this image is both physically and conceptually bonded to the material. It's inseparable from the material. And that if we're going to describe an architecture of recycling, the architecture of recycling must inherit the vestiges of its the material's former use. That is its inherent language. And there's a sort of back-to-front, form-to-program kind of argument about functionalism and aesthetics in this. Probably won't want to go into it at this stage. But this is the material, 5/32 thick. By the way, I'm from England, and it's taken me a long time to start thinking of things in terms of 5/32 of an inch, but it's prerequisite to try and getting tenure in America. So this is 5/32. You're probably talking millimeters, you guys. In Arizona alone, an average year produces 156,000 sheets of this board. That amounts to 65,000 cubic feet of landfill site, or to put it another way, a stack about 2,000 feet high. I think that's the height, just about the height that a jumbo jet reaches as it passes over the edge of over Mesa in Phoenix. Just going out to, I'll be able to relate to that, but anyway. And the project really began, so this is really a description about how those aesthetic values really, in a sense, drove the project. It was driven by a lot of technical considerations and very immediate sort of pragmatic requirements. But I felt throughout this project that there was a real driver that led below this project, which was to do with the recycling of political imagery, and that kind of motivated people in a certain way. That sense of recycling or repurposing of a material then permeated throughout the rest of the project. So it was a very simple model that we came down to as a way of starting off formally. So this shade structure has been broken down into a cellular structure of hexagons. One of the hoops it had to jump through was it had to be stackable and tessellated. So the hexagon then was drawn into, had something like a 4% draft angle on it so that it could stack. What we didn't really understand at that stage is that the moment you do that, you compromise the geometry of the hexagon. So actually it's composed of four different types of slightly different geometries, slightly different hexagonal geometries, but they all stack together, and that stacking is actually crucial for the success of the project in being transported from one site to another one. But as a result of that, we got this domed geometry. What came first, I don't know, really. So a larger accretion of that, and then some quick drawings on the side of it. And this is that process of formation, of starting with Fulton's 8x4 sheet of polypropylene ply. It then goes through the forming process where it's cut into strips. There's scoring, folding, and it's a bit like a Russian doll in the sense it has concentric hexagonal geometries, one fitting inside the other. And then it's clad on the outside with a shading device. This is one cell broken down. You can see the 4 cell sizes on the left, and then one cell broken down. So what we're using is this material, but we're also laminating it, 2 layers of it. We were trying to arrange it so that the fluting within the material ran at 90 degrees to one another to build up its strength, but we were compromised really by the cutting pattern, trying to get it out of an 8x4 sheet as best we possibly could, with the least possible waste, really. So there's a reduction of waste, but not a complete reduction of waste in that. And this is the fabrication process here, and this is a drawing of one of the cells with a shade canopy over the top of it. The drawing second from bottom, you should note that it's riveted together, and that's how we really fixed it together. But this is the simple process of scoring and forming it. Part of our brief really was to say, ask ourselves whether we could provide an alternative to the sort of generic thing they call the easy up, that you see at all shows and festivals, that white tent, and could we do it really in practical terms? I think we failed in that respect, but that really drove us to try and think about the material affordances, the ease of fabrication, really, and in particular aspects of transportation. So this is it being That's the scoring process and forming process of one of the cells. And then this is the sort of way that each cell was mechanically fixed together. Students, once they sort of hooked onto the idea of it being a hexagonal thing, became like these sort of notional, sort of conceptual bees really swarming around it and putting it together. And we got stuck into this process. And of course, what was driving us all the way along was what might be described as a chance kind of exquisite corpsing activity of this iconographic political imagery, where Fulton's daughter, I think she gets juxtaposed against her father's elbow at some point, hairy, manly arm, sleeves rolled up, sort of friendly political, and the rivets arriving in sort of uncompromising ways, smack in her forehead there as well. Fulton Brock hasn't seen this, and I hope he never does, to be honest. So the next sense of that, once we were working with this ply, that thinking started to permeate everything else within the project. So this is a repurposed Voss bottle, and its role is to provide a kind of hand-driven, what we call sort of haptic experience of cooling within the desert. Yeah. Now, I mean, Phoenix, irrigation equipment in Phoenix is absolutely de rigueur. It's everywhere. You buy it, it's very cheap. And this is the Voss bottle. It has two misting heads in it, a valve and a bicycle valve and a high-pressure hose, and that's simply what it is. And then and that's the value of the whole thing. Comes to, very little money. It was recycled bottles. Here they are, just a few of them all gathering, ready for the event, of course. And this is how it works, and it works in the field. The shade structure had to be a standalone shade structure. It couldn't be hooked up to any services. It had to exist in many different environments. And so this is how the Voss bottle works. It's just like taking a drink to an event. You have a bottle full of water. And yet this bottle, with the aid of a bicycle pump, you can pump it up reasonable pressure. Half a bottle will provide about 20 minutes misting. This is underweight, yeah. And these are them hung like sort of strange, obscure pieces of fruit from the underbelly of the structure. And that's it being installed. But the current thinking in terms of environmental engineers in Phoenix is that misting as a form of cooling, which is incredibly common around bars. What you see bars sort of draped in a cloud of mist, a little bit like sort of rather sort of cheap vernacular versions of Liz Diller's project out in Switzerland. They're draped in mist, and that mist carries out the kind of cooling through particleized water. Now, the current thinking about that is that airborne pathogens make this incredibly unhealthy. These pipes gradually gunk up with nasty things, and then that gets thrown into the air. So the thoughts now are that you would create a kind of a wicking action. So here the misting is there, and the mists onto an organic cotton kind of pajama material, soaks it, and then that produces the cooling where it just dumps cool air down. And we got a reading, depending on conditions really, of something like, a very modest estimate of 5 degrees, sometimes up to 10 degrees, 3 feet below the canopy, and depending on how windy it was. But we're talking about temperatures that are really consistently above 110, so kind of hot in a way. So that's a diagram of how that works. In addition to that, we worked on a method, and we got only so far with this one, but of embedding a kind of embedded approach to the digital here, whereby we built in these heat sensors that could provide Bluetooth connection and then a web-based service for seeking out heat sanctuaries within the desert. These operate on there's an equation that's delivered from three different temperatures that give you a heat stress index. So this is big business when you're a construction worker out in Phoenix working out in the heat, is that your company is legally obliged to keep your heat stress levels down. It's not just being in the heat, it's being in the sun and then evaporation, so on and so forth. So we're appropriating that kind of infrastructural piece of technology and developing a kind of a website where you could seek out heat sanctuaries within the city. Again, that issue of recycling was then, let's say repurposing, put it another way, came down to dimensional lumber, of course, which is a vast amount of dimensional lumber is cast off from building sites, predominantly stud construction. And our method really was to develop it into a glulam structure, which is kind of unifies it, breaks it down and unifies it. So this is what happens. Any 2-inch piece of dimensional lumber can be ripped down into 1/4-inch strips, which have a bending tolerance, particular bending tolerance of, I don't know, something like 30 degrees over 2 feet, which allows us to prong out at the top of the capital of one of these columns enough to counteract the bending moment where this thing connects to the underside. Again, very simply bent aluminium and steel connectors and ball joints to give us a certain amount of flexibility where the structure kind of moves, and we've got to make that prong connection to us. And essentially, I mean, it's not a rigid structure by any stretch of the imagination. And this is how it connects. What you're looking at here is the underside of that connection going up to the roof. From the cylinders and there's a blade that runs between 2 levels of the laminate. So you've got 4 levels of of this plyboard and a blade going between it, attaching them together. Again, another angle. And then to the feet as well. The sort of vernacular of festival easy up tents is that you make the tent and then you think, okay, the wind's going to blow it away. I better tie a sandbag to one of its legs or a jug of water, and this thing hangs there. So what we decided to do is to try and inherit that idea and integrate it into the foot of the structure. So this is an unfolded extruded pyramid here that's connected by Velcro tabs, and it wraps around the foot in this manner. And the Velcro tabs allow you to open and close it, put sand, pebbles, something in there just to keep keep enough weight to counteract the vertical forces when it gets windy. We also devised a foot. This is going to go on show in the gallery in Arizona. But they're very precious about their floor, so we wanted to be able to move across a series of different terrains. There's actually a spike foot, an alternative to a spike foot that sticks into the ground. This is a cast urethane foot. It was developed just by a simple doubly curved surface that, it's not a doubly curved surface, it's 4 developable surfaces, pardon me, parallel cut into a male mold, and then a female mold vac formed off the top of that, and then the foot's cast in urethane underneath it, and it sits on the underside of each one of them. This is unfolded foot, and you can see the Velcro where the thing comes together. And then on to more sewing here. I mean, it was really like a sweatshop of American students converting these pajamas into shade elements that sit at the top of the thing. Incidentally, with the evaporative cooling process, it's important to keep direct sun off the top of the wicking fabric, so that's why we have 2 layers of fabric here. So this is stretched over the top, stops direct sun, but allows a certain amount of air through. Then the wicking fabric lines below that. In terms of installation, really, I mean, this, I don't need to tell you how good at this kind of installation work American students are. They're extremely adept at putting things together. They tend to be a kind of ability to work with their hands in a very real, practical manner. They love carrying them all in one. I mean, you can carry half of it with absolutely no problem. I didn't have any problem with it. This is it in the field, and that's whole one. That's the whole kit there, sort of spread out, and together as a set. So you've got 2 concave and 1 convex one. And this is the nature. I mean, the light is extremely sharp, and the sun, as I say, blazes down 110 degrees. So the opacity, the density of that shade is extremely important. And then this is it in its second location on review. It's currently in the 3rd location of the foyer of the architecture school. And as I say, it's going to go on exhibition, an exhibition that they're having at Predoc's Art Museum in Tempe, ASU Art Museum. It's at the festival position. We have some views of it from the underside. Just by way then of just kind of concluding, I don't know how I'm doing, Alan. So that's a long-winded, really, discussion, or the ins and outs of this process of reforming something. The computer was quite absent in this one. I think I'm probably the only entry that doesn't have a Grasshopper script in it. If I did, it would be noticeably short. So I left it out. through reasons of embarrassment. My real interest in this, and it's a sense of how one learns to, the process that you have to go through in order to gain affection for something as unlovable as American Republican county supervisor, and give it a kind of craft affection, which I think we achieved to some measure of success. And that affection was really born, as I say, of what happens when you cut these things up and reuse them. The wider discussion about repurposing, trying to avoid the word sustainability, but discussion about repurposing is that the former life of a material is inherent in the final architectural product. In this project, we can't really describe it. I mean, I had this material knocking around for a long time. I was really looking for a project to use it on. So in this sense, it's that aspect of it was a form to program type thing, although the functional requirements of it were very much a functionalist argument, program to form. The camps are very divided on this. I'm not really. It just jumps between one category and the other, form to program, program to form. I can't decide which one to settle on. It was successful because there were, in some extent, coincident programmatic requirements between the before and the after, in that this political plyboard is, it has to be weatherproof, resisting the sun, particularly lightweight and sort of disposable. And again, those terms could be applied to the easy up structure that goes into festivals. We were fortunate, similarly, that it had a sort of an as-found kind of pop kind of graphic to it. The students were subconsciously talking about Liechtenstein or something that they looked like Liechtenstein. Appropriately, too, that this appears on American street corners, every street corner, episodically sort of blooming like some weird plant at intersections during campaign seasons. That sense of the street corner is also important. Leads me to that axiom from Rauschenberg that architecture could be like art. You make it from what you find on your own block. And I wonder where I've heard that before in this environment. David Green's not here. Thank you very much. Thank you.
Hi. I'm Tobias Walliser. I'm one part of LAVA, representing the Stuttgart office. Chris Bosse, who actually did most of the work, unfortunately can't be here. The travel from Sydney was just too long and we couldn't find any good combination of other things. Would have been very nice to be here together, since a lot of work is done in a digital collaboration, actually, which is one side, which is difficult as it is, and we always appreciate if we have more time sitting together and just doing it the old-fashioned way. Maybe just a very quick word about the office. Actually, on the left is where we come from, how we met. We haven't met at graduate school. Both of us have extensive work experience. Chris designed the water cube. I was co-architect of the Mercedes Museum previously. So that is actually how we met a couple of years ago at the Biennale in Venice. At the right side is things we're working on simultaneously. What we're trying to do is, whilst working on projects, also still seeing work as part of an ongoing research process. It's less the academic part, is actually more coming from the practice. So while we're working on this tower there, which is a fully Grasshopper scripted project, we also did some other thing, the Green Void, and I think that's, unfortunately, it's another project that doesn't have a script in the background. One of the things all of us at LAVA share actually is the background that we studied in Stuttgart, and if you study in Stuttgart, Frei Otto is actually the big hero, and that's, in terms of research, is what impressed all of us on various levels. While Chris was working with the soap bubbles, and come back to that in a second, I was working at UN Studio, and this twisted concrete element at the Arnhem train station was actually something that came from minimal surfaces and knots, but it's also going back to the idea of the soap bubble. This is a minimal surface that wouldn't be possible to be done as a soap bubble, but nonetheless it has similar properties. So that would be a digital soap bubble. The other thing we're more and more interested in is the rules of the process. So what are the rules of the game? Something can appear rather complex, but there might be an easy process where with one process you can generate a lot of diversity and different qualities, not only quantities. So we're not talking about transformations, we're actually talking about something where elements get added or taken away while still using the same process in the background. The other thing we're very interested in is actually the aggregate of smaller units which assemble into something which is more, where the whole is more than the sum of the parts. And part of that is all going back to the study that was at the beginning of the water cube, looking into coral reefs and natural elements. This was the first study, and then it got more and more complex. I don't want to show much, but so the idea of working with the bubbles, and the bubbles, to get it built from this one to that one, there's a lot of research process, and the understanding that this, going back to soap bubble geometry and to actually two polygons, 12-sided and a 14-sided object, which can be assembled in a very simple way. I mean, the trick in this water cube, it's a repetitive structure, but the structure is actually tilted against the cube itself, and that generates something where you don't see the repetition. It is a totally repetitive structure, but it doesn't appear to be repetitive just by the tilt against the horizon. Working on this, of course, the best part of the water cube, I would say, is the cafe, which is the space on the right side. Chris started exploring the potential of these forms on a different scale, and that's how the digital origami came along, which is also part of the exhibition, which is working with students on these, taking only these two objects, the 12-sided and the 14-sided object, and assembling them in various configurations, just really exploring the spatial quality of these small units, which is something which came directly from the water cube. The other one was actually looking into something which is less repetitive, rather than working with the repetitive objects and volumes, just looking at something which is a stretched, is a minimal surface where you determine, you don't start with a volume, you actually start with lines in space. And from these, they're stretched to the edges. Actually, this one should rotate. They're stretched to the edges, and you get these minimal surfaces that look, for instance, like this, which was the Entry Paradise Pavilion 2006 in Germany. The process from there is a direct digital fabrication. This element is broken into pieces. These pieces are laid out in a very efficient manner, and then they're directly cut and sewn together. This is a very lightweight structure. It only weighs, this one was only 30 kilograms. You can travel it. Chris took it in the bag when he came from Australia. It was manufactured in Australia. It was on the airplane, taken on the train, and then directly shipped to Germany. The whole trick about these is, of course, that you don't have, it's all suspended from the ceiling. It's just hanging down. The only thing, it's a lycra fabric. It's only stretched by some weights at the bottom. When we were asked to do an installation at Sydney's Customs House, we're actually trying to take this further and really, give a totally different idea into that building. We were asked actually to do an installation about our work, but rather than just displaying the projects we're working on, we thought the best thing would be to really take over the building and transform it into something else. So this was a light installation with a slideshow on the outside of the building, which is actually already revealing the green void on the inside. And then on the inside, it was the idea of having something which is literally suspended from the top, doesn't even touch the ground in this case, and just funnels out to the sides and this is an office building actually. There's the Sydney City model, which is at the bottom. There's a glass floor on top of that. There's a library, there's some offices, and there's a restaurant in the top. And the idea was using these funnels actually as something generating new connections between the different elements. You can look into it. There's something which makes you aware that there's the big space, but the big space is actually also connected in new ways. So this is the digital model, which is actually, it's done in 3D Max, believe it or not. We test it always in we always test various rapid prototyping elements before it's cut up into different pieces. Here you see the different parts. These are laid out. This is the entire a cutting pattern of the green void. And the next step is actually the only other thing which is needed is a couple of aluminum tubes. You see that at the lower left side, and the fabric itself, in this case, it's 40 kilogram. What's interesting in there is that 40 kilograms of fabric can actually turn 3,000 cubic meters of space into something completely different. The reason why we choose for the color is quite obvious in the image here. It's something where the reflection and so on becomes part of it and transports this idea further into the building. It was all done up in only half a day. It was quite tricky in a way to make sure that this was really in balance. It's only suspended by very small rods, and ideally they're as invisible as possible. I think that was achieved quite well. This is actually the view from the top down. And the most important thing about this object is actually not only the object itself, it's the way it interacts with the surrounding. Things happen where places are totally appropriated in a new way. And for instance, people working there in the library suddenly had this green intruder in that space, which was only meant to last for a couple of months, but they decided to leave it for half a year, and now that it's gone, we hear a lot of people complaining that actually something's missing in the building. The other thing was, what this was used for quite extensively was actually for parties. This is a location where a lot of people have their wedding celebrations at the top, and we developed a system with a very simple lighting system and some patterns which were more or less derived from the 3D model, or at least they were tested and mapped on the 3D model, how we could turn this object into something totally different. It's basically a canvas. I mean, all this is a lycra fabric, and the most tricky part, because it's a public building, is actually that it has to be treated with a flame retardant liquid, and you never know how much that influences the stretching. So we had already some parts that needed to be redone. Or the other thing is, we were trying to hang this up in another space, but then it needs to be cleaned, and no one wants to take the guarantee that the material properties will still be the same afterwards. But as I said, this is part of an ongoing process, and actually one of the spin-offs of this one is less known. We developed something, the MTV Awards Australia came to us and said, we love the green void, can't you do something like this for our MTV Awards? And we say, well, it's no problem, how much time do we get? And they say, well, unfortunately, you have 3 weeks. It needs to be up in 3 weeks' time. So we started doing something like this. The difficulty on a stage set is actually that rather than having something which can be suspended very nicely in a vertical environment, this is more horizontal, and that means that you need a totally different configuration of these elements. But still we were able to make it, and that's largely due to the knowledge about the fabric itself. I mean, it's the software, there's a relax option in the software, and if you know the right parameters for this fabric, it's relatively easy to reconfigure it to any of these minimal surface shapes. This is actually the stage set for the, as it was used for the MTV Awards. Unfortunately, these are not moving. And the best thing about this actually was there was a tunnel, and the tunnel was very empty, so they came back and asked, can we not have the digital origami in there as well? And this is actually how the digital origami appeared on MTV several times. And this is part of where the circle actually closes. So it is something where we're commissioned to do something rather than a specific research project going into depth. It's rather something which we're pursuing alongside our work, and every time we take it a little bit further, or we try to give it a new direction. In this case, which is unfortunately not working, is actually in this case the projection on the image was very much perfected. So that was from the beginning, part of that is an installation where we took the cutting pattern and so on and projected that back onto the image itself. And that generated a totally new idea. It is already a very, very lightweight structure. Only one person can carry it. But then if you project the digital cutting pattern and so on of the whole of the fabric onto itself, it's transformed into something totally different. And it actually, in this case, it was used as a background for all different, for music as well. Thank you.
My name is Nick Bruscia. For the past year, I've been a researcher and a professor at the University of Buffalo. Previous to being a researcher there at the Center of Architecture and Situated Technologies, I was a student just over a year and 3 weeks ago. And this is the research that I'm going to be presenting today is part of my thesis research. So first, the term allotropic, perhaps I should define. Now, largely, any of these structures that I think a lot of the presenters have been talking about probably can fall under the category of allotropic. But I chose it because of its use in material chemistry, in the field of chemistry, and I'll get to that exactly why. But to define it for you very simply, in the natural world, there is an occurrence where the variation of the arrangement of atoms within a specific element will create different materials, such as this here. This is the element carbon and how it produces both graphite and diamond. So as you can see there, simple variation, right? I mean, here you have a tetrahedral lattice, which is quite strong, versus an almost unstructured layering of the same element to produce something quite soft. So I was interested in sort of, I was influenced by this term, and this led me to kind of, it led me to be a little bit more sensitive about the material contingencies in the event of their making. So the project was split into 4 avenues that I'm going to try to outline for you briefly. The mold, the tool, the system, and the machine. All of these create a certain process, right? This is what the project was normally about. It wasn't really a formal exploration as much as it was an exploration in a certain type of working or fabrication. That fabrication, what I choose to actually work with was casting. So what I'm going to explain first is the mold. So the reconfigurable mold is absolutely central to the research, why I'm starting with it. Now, what I was interested in doing was actually making elastic, flexible molds. Here, this is a first very early study, actually. Up top is just a static mold that creates the mold. If you're working with molds, and if that's your final product, you need to make one to make that, which is also sort of a part of the project I won't really get into as much because it's very detail-oriented. But here, all I'm really doing is studying a certain type of rubber, which is silicone in this case. The silicone rubbers exhibit a great deal of elasticity as opposed to urethane molds. So here I'm looking at just the different, very simple types of variations that might occur when you kind of just bend the molds, right? I didn't really get into the stretching of them quite yet. So in any event, I think the process of casting represents a simple positive to negative relationship, but you can almost liken it to a parent-child relationship, right? That the child is born of its parent. I was interested actually in the child being able to, let's say, reform or let's say have a bit of influence on the parent in the process of casting. Here actually is a study based, again, on silicone rubber. However, here we've got an issue, right? We've got a leak. Now, part of the problem with elastic molds is that you need to have a seam that is watertight, right? But you have a pretty interesting design problem that I haven't really completely addressed yet, but I did find at least a halfway solution for in the final piece. And because the deal is that you have to open it, right? You can't weld, let's say, like similar to the pneumatic project, but holds air with a very nice PVC welding. This needs to reopen, right? So what I started to do here was embed a mechanical fastening within a material that just completely resists mechanical fastening. And as you can see, the viscosity of plastic in this case is just like water, meaning that it failed. So moving on with it, what I decided to do was a very simple solution was to create a rigid outer shell and allow the elasticity itself, instead of just the bending of possibilities of rubber, but allow the elasticity itself to actually create the variation within the piece. So what happens here is with the magenta color interior mold is actually a much more elastic silicone rubber that is fused to a much more rigid silicone rubber. Now the two rubbers together allow this fusion to occur. One is cast first, the second is cast into it, and they become one and the same. So there's embedded acrylic pieces, and not to get too much into detail, but that keeps the watertight seal. Now, as you can see, there's somewhat of a specific form that develops inside the interior mold there. I'll get into the problem there. Now, I actually solved the problem of this kind of exterior leaking, but what happens is as soon as these things are sort of stretched from the center, they leak on the inside, making the unit a bit imprecise. So I'll get into that a bit. Now these molds, I should mention now that these molds are heat sensitive. So this is the big idea of the project. The big idea of the project is that this reflexive process, which is to say that, as many of you probably know, when liquid materials are put together to create a solid material, there's a chemical reaction that occurs, and it heats up, right? So I was interested in actually being sensitive to that process so that there's a reflexive process between the casted material and its reformation is in fact determined by that casted material. So the idea is that different materials placed into the same mold would perhaps yield different results depending on the system or the tool, which is what I'll explain next. So that here, okay, just really briefly then, as I said before, the fusing of the outer mold to the interior mold, here was just a couple static molds that were done to, here is just the prototyping process or the fabrication process of the mold itself. Here I'm pouring into it with a much more elastic material, and it fuses quite nicely. So this is just the first working prototype. Here just a small little bay. Now, eventually what I proposed and what you'll see later is that these molds are actually networked. There's a series of them. Here I just needed to study one of them, and there's a small bay of silicone rubber, heat sensor embedded within it. There's a microcontroller that is able to sense this, sense the heat gain in real time. It sends that through a very simple generative algorithm. Not in this case, but in this case here all we're really doing is determining how long it's taking for this material to completely peak at its heat. As soon as it starts to drop off, the mold is no longer stretched. So, oh, that's really disappointing. This might have been the warning. Oh, I'll just stick with this. Unfortunately, there was a video here from Jean-Luc Godard's 2 or 3 Things I Know About Her, a film that you may know about. And there's the coffee scene in that film is actually quite beautiful. And there's a zoom in on the coffee being stirred. And it really excited me because here you got, I mean, what was actually happening, there was a stirring, right, and there was these bubbles that were forming seemingly out of nothing, right? They were just kind of popping up to the surface, right? Now, what's interesting about this is what I got excited about in terms of chemistry is all the different parameters, and to me it was very computational. It was like it was this account and this almost like a documentation of sorts of a very simple computational system, which here the parameters being the heat of the liquid, the amount of sugar dissolving, speed of the stir, diameter of the cup, etc., created this kind of formation. So what I did was I started to abstract something similar in cellular automata. Here's just a processing sketch that takes a look at several generations. This is a Game of Life script that takes a look at several generations of cellular automata in terms of self-organization. Then started to apply that very simply to sort of a skeleton that might become a structure. Here the unit isn't yet defined, the module isn't yet defined. I had to look at, I was also kind of excited by ivy, the growth of ivy as it searches for heat and moisture. I like very much its propagative ability. Here I'm just, the density that you're seeing with the kind of the circles down here is basically just, it's generation by generation of the CA being applied and then extruded in the Z dimension. Here there are a series of units that overlap, creating a certain structural configuration. So here is what I mentioned before in terms of how that first prototype worked. These were analysis on different types of materials being cast. The gray bar is, in fact, where it reaches its peak heat. The materials, I think it was 4 different types of plastics, concrete and plaster. Concrete takes quite some time to heat up, and I mean actually the diagram for concrete isn't here because the bar was actually quite long. It was like a 6 or 7 foot diagram and a very small size. So it was interesting to see these kind of, even with the plastics actually, I think the first one and then the last 4 are all different types of plastics. And they're quite similar, except if you can see with 4 and 5, there's this kind of spike, right? So here is where the networked molds come into play, which is quite interesting. If one can affect the other, you're pouring into that one while it's already stopped its elasticity phase. So meaning you've got this other degree of variation built into the system. Now I moved on from the CA that you saw previously, which was the Game of Life CA, into a one-dimensional Wolfram CA. I did that because it was time to apply this to an actual machine, and I'll get to that next. Now the application here is simple. If there were 8 molds, you have 8 cells up top, which define an initial state. Now here's where the designer comes to play a bit in working with the machine, as such that the sequence of pours in this initial stage actually activates the rest of the structural configuration for the allotropic system. All right, so to be more clear about that, in the gray, let's say in the first image, there are 3 gray dots. That is perhaps where the designer decided to pour those 3 exact molds. As soon as the system is initiated, it goes ahead and creates this blueprint. So a little bit about the system then, and talking about to explain this a bit more in terms of how it actually creates a structural configuration. Well, what's represented here actually with this grid-like image is actually 2 layers. So this also accounts for a connection detail to be designed. And these images aren't actually what's pushing the molds, but at the same time they're developed in real time and then saved, so that later when the modules come out, they can be put together in a specific organization based on the event of their casting. So just a couple, let's say, representational models. I tend not to call these prototypes because they're not performative. These were 3D printed, and they give me an idea perhaps of what the spatial consequences of a system like this might be, but they're in no way performative structurally. So I tend to think about them as digital models. So just a few examples, let's say speculations on what an allotropic system might become in this way. Obviously now the unit can be designed in different ways and embedded into a similar machine. So the machine here is also a prototype, I think, version 2, very similar to what you saw before, but it was a bit tweaked. This is very simple. Obviously, it's just illustrating what I mentioned already in terms of pouring into this little bay, which had this heat sensor in it. Now, this bay represents another mold in a larger machine, right? But in this case, it's very simple. Now, to show a video of this would be kind of a moot point because it's very slow and it's actually quite boring. It just, every now and then there's a little jog in the action. To me, it was quite exciting, but for the purpose of the presentation, I think photographs might work fine. Here's the demolding process. It actually takes quite some time, which is also something I'm working on. Interesting enough, I was trying to address digital prototyping or digital manufacturing, and yet I completely negated the possibility of speed in that process by making this system. And I was actually okay with that in some ways. Now here you can see the little, the issue that I'm having with these molds, right, is that you see in the bottom 2 images, the unit itself can't become very precise because the material doesn't hold together enough, right? There's a weight of the plastic that actually pushes these things apart, and there's a little bit of overlap that occurs, which means now, in this case, you'd have to go through and actually fix each piece. So this is something that I'm continuing to work with. Here, actually, what I didn't explain, there's 2 images there, or there's 1 image there with my hands, and I'm kind of like poking at the rubber. What's interesting about the silicone, and as part of my material research, is that it's quite tacky even when it's cured. So what I was hoping was that it would just stick together for long enough that it would keep the cast. It worked for maybe 2, and then it started to break down. Dust or whatever would start to break it down. As soon as you wash it, you lose that kind of tackiness to some degree. So the final machine, as it sits now, I tend not to think about it as actually a final machine. It was what was defended for my thesis, but I would like to project the project forward, is represented here. And I'm just going to leave perhaps this image up. I'll talk a little bit about its context. Now, I was also quite influenced by Johann Wolfgang von Goethe, who defined morphology as the study of forms by laying the foundations for systemic methods of observation. Here, within this laying of foundations, he provided a distinction between the Gestalt, the structured form, and the Bildung, which is the formation, the changes that the structured form go through within its formation, or which is sort of an ongoing process. And so what I tried to do is actually fuse the 2 together, right? So now, of course, one would have to, when you're creating molds, there needs to be some sort of, I don't know, prescribing of what the cast is going to come out like. So there's design there, which is in fact to me was the gestalt part of the project. But what the molds, with the flexibility and elasticity of these molds allow me to then do is address the Bildung, which is the formation of the casted piece, right? So that was kind of, actually where I kind of started with, and this is kind of what my answer to that, to trying to fuse these 2 things together was. So the idea here is that what's interesting, I think, also about this project, within the context of this conference, is that is these diagrams that I think you mentioned in the beginning, that Alan mentioned in the beginning, and mine were very amoeba-like, right? I didn't see, at least in this project, there wasn't a clear distinction, I don't think, between the architect fabrication process and the final outcome, because they all have design agency. right? The material itself is able to determine a bit what its outcome is going to be. The designer obviously sets up the system and actually pours into them himself or herself. The machine is actually what defines these, through networking, through sort of networked molds, is what kind of defines the structural system, and the algorithm also defines the structural system, and in fact how much these molds are able to stretch and reform the casted piece. So to project the project just further, this is just my last slide. This is actually a very early study I did, and I'm using it in my last slide because I found it to be very interesting. But I couldn't, now due to, oh, actually, one more thing. You're seeing 3 molds here, right? Now, as a thesis student, my bankroll started to dry up a bit, and I couldn't produce 8. So the way that this working prototype actually functions is quite different than the CA that I represented before, because it just simply can't create, let's say, a lattice structure of 8 units wide. But it was the code was reappropriated to fit that piece. And anyway, this was an early study where I was looking at very simple actuation methods to produce a more global variation throughout the entire mold system. And here it was just a spiral actuation. Now these umbilicals, these latex umbilicals, were spiraled through this series of molds, which were also elliptical, meaning that there was a different control point on each mold, allowing, let's say, just one stretch to actually produce slightly different results in each piece. Now this was an issue because I hadn't yet developed, let's say, a proposal for a watertight seam. But here is where I think it's actually a nice first study on how to make the machine that I showed as my final piece to become less rigid. Right? The machine itself, I'm talking a lot about flexibility and elasticity, and yet the machine itself is very simple. It's actually a very rigid framework, and it's just actuated from the center each time. Here we've got a slightly different, we have new options of actuation within each responsive piece. And with that, I would just like to quickly end with a quote, also influential by Paul Klee, which I find quite nice, which is not form but forming. Not form as final appearance, but form in the process of becoming. Thank you.
I'm going to switch off all the PowerPoint. Let's do it fast, 10 minutes. Should be the first one. Well, wait a second. Is it on there?
Okay. Yeah. All right. I don't know how to introduce ourselves because we are a bit complicated organizations. Myself is Shine Gashira and my colleague Rubens Adesivo. But there's lots of people who involved in the project, which I can describe whole history, but it's almost impossible in a given time. So I just wanted to say also thank you very much for cluster organizations, also number of the sponsor. And also apart from one thing I have to explain is that this whole project started from one thing and led to another and developed much further, then branching off in many different routes. So then in the beginning of it, I just wanted to start from this project we've done at the AA, revisiting the David Green's theoretical project, which took place in a couple of years ago at the AA. Something I have to do is take up his kind of a project which looks almost incomplete and try to make a model by using some technique. So in a way, one of fabrication, if there is a research, try to revisit basic research by materialize some theoretical project through which maybe another interpretation may come along, or technique we use enable to perhaps possibly contextualize some project which suspended about 20 years ago. So and also, sorry, I just forgot the order of it, but Rubens was very exhausted today. He's been driving the van for many miles for setting up the exhibition, carrying the prototype from Hook Park, back and forth. How many miles? About 1,000 miles, I think he's done in 1 week. So he claimed he's too exhausted to speak, so I do majority of presentation today. Yeah, unless if you know wedged in. Yeah. So this loan project, where do I? Yeah. It's about 3 projects. One of digital camouflage jacket. Other one is stuck up highlights living pod. And one project I was given is mosque in Baghdad, which are kind of organic forms which resemble some of Kiesler's projects in terms of geometry, but not widely published before. So what do we have to do in the beginning is try to read his series of sections, plans, then breaking down into geometrical component. So there is lower part is attempted to draw through the ruled surface, through parabolic, and also to make sense of entire compositions. So there is 2 A and B patterns, which if you break down into those 3D curvature, breaking that to cube, and pull in 3 different directions. So you got only 2 different types, but because of the proportions of it, you could describe quite various forms, which are also structurally possibly make sense as enclosed volumes somehow. So these are series of models, materials, and stretch fabric. And interesting things is all those minimum surface can be simply described by 4 different sections of the curved surface, which stretched. Then you just try to estimate minimum curvatures stretched in between them. So the easiest way is by panty stocking and stretch them between those sections. So those models. Next stage, from those basic patterns, solidify those curved by layering plaster over the fabric. Yeah, so formwork, models, and geometry. Kind of final piece we call the prototype. So that's how our kind of technique evolved from. So also another organization we've been working on the support of Maeda Corporation from Tokyo. They've been supporting generously for the certain material research for over last 2-3 years based in Hook Park. So when we enter the FAB competition, we are working with technique of fiberglass reinforced concrete techniques, try to achieve certain geometrical forms somehow. So those are the list of the people. Some people stay for a while, they get busy, they graduate, get the job, move on to something much more creative. Some people have more time, so keep us on staying on. Some people pop in, fed up and left. Some people still working together somehow. So in a way, I think that's the kind of difficulty of fabrication process, because I think what we do is probably we isolate ourselves from any other problems or criteria, isolated ourselves to face with materials and techniques and tools, and we just work with it. So in our case, basically, actual materials, details, and forms. That's the only matter thing somehow. So in a way, we don't know what the outcome is, and we don't know how to finish. So just carry on evolving one thing to the other. So the one piece we eventually won this competition, we still don't know what it is actually. We exhibit in that space. So that's one reason we keep calling some ambiguous name, like urban toys, urban furnitures, playable structures, and so forth. So anyway, so I think here there is an initial stage where we're testing materials. So when we cast, next things we do, we try to break them. So certain lengths, certain composite between sand and cement and fiberglass, chopped in different lengths, different proportions to achieve strength by test pieces. Anyway. Oh. So these are ingredients we started with: fiberglass, cement, plaster of Paris, Vaseline is very, very important. Hardener for concrete, polymer for concrete, plastic sheet, and also copper tubing. The basic materials to start with. These are initial phase when we started initial session workshop with Maeda workshop. We were giving the site on downstairs in dining room. So one of the ideas is try to revitalize their back walls by certain new installations. So this video shows certain principle of how the block cube, simply series of curvature sections being drawn on the cube. We establish A, B, C, D patterns. And all those block model is kind of puzzle, so generated from 4 different section line plus mirrored image. We managed to make something like 96 cubes out from same different combination among those 8 patterns. Then each cubes have a different curvature. So I don't know how to explain it, but anyway. Yeah, so those kind of 1 to 5, or is it 1 to 10? 1 to 10 models. Yeah. So these are kind of a series of test pieces generated from those formwork. And as you see on the right-hand side in the bottom, those are one of the formwork cut out from CNC machines, stretched fabric, painting, plaster again over, and what you get is a very simple form of minimal surface, which solidified by 6 layers of plaster with hardener. So you got open cast patterns over which, no, there's another, I think this moment we use the grasshopper somehow. Sorry, Jason. But anyway, those are kind of rotating forms, and also there's a moment when, see, that's wobbly things happens and fix into whatever, and CNC machines. So it's a part which we felt that we are actually working digitally, but in fact, all sort of representation remains, either try to speculate light effect and how those curvature would meet each other. But we try to find a way to from this information into fabrications, but it's suspended to the last minute to really try to explore that actually. Anyway, so these are drawings and the formwork for the wall unit downstairs. These are all discarded formwork after we cast it. In fact, these are as beautiful as actual piece, I suppose. Yeah, we did a barbecue and we had a nice meat. Just private, quite unhealthy, but anyway. Yeah, this shows some kind of moment when we also those speculative works going to labor intensive period. We pasting layer by layer, stretching fabric, and assemble each piece by piece, and section has to be correspond to different sections. So fragmented landscape into assembling, then installations in dining room. Details. Then FAB things is overlap towards last part of this, and we begin to think about another applications. Also try to contextualize either called urban furniture piece or interior piece or whatever. So these are one of the piece also in this first stage of competitions. We try to make some kind of component which are merged and joined together or split. So there's simple model which piece hinged out, joint, become one piece, then moves, joint back again, and separate. So it's very, very simple things, but we made this test piece which managed to squeeze 3 people in, but somehow something wrong happened when we transferred to CNC machines. Scales was somehow 50% smaller than what we planned, so we got kind of little baby chairs component somehow. Yeah. It actually fit. And the other part is the joint piece, is how to really join two sections together and make sense in 90-degree rotation, have another section to correspond. Then again, those kind of digital form of a 3D model, it's actually quite useful to actually play with it 3-dimensionally, matching and collecting it as well. So then next stage, we introduce this pipe, half-inch pipes and 3/4-inch thickness steel pipe, 4-meter longs. Idea is try to not to waste those formworks, as I showed in before, the plywood off-cut. So this pipe works, you could describe certain edge of the geometry, but same time it can be integrated actual surface structure. So but again, we lost lots of pipes. Those are all those waste. I think there might be 10 times more than what you saw in these pictures. But what we do is try to bend certain lengths, then try to determine certain forms we can manage. Only one tool we had is plumber's bending machine on those curvatures. We cut lots of series of diameter piece and extending those arms. So we managed to get something like 4 different radius, which can be also equally twist. Fortunately, I don't have a photograph of those most important pipe bending jigs, but anyway, you may get sense of it. Another technique is again tube bending and stretched fabrics, same as before. So these are little models we consider the drawings. So when we do this kind of group work, we set out certain materials for model, this case drafting tapes and copper wiring. We make lots of them and just group them. So we start giving the name, like bent over carpet, cow, diapers, or whatever it is. Then group them, then try to make series of test pieces. So these are kind of, each one have a certain geometry by stretching patterns. Some are enclosed, some are open form. Plastering again. And then taking plaster off, as you see, those edge is thickness of the concrete determined by diameter of the pipe. Another furnitures. This is a cow pattern, which also there's a little model we made by plasticine, and we covered mapping those surface by patterns of the, when you cover with drafting tape and cut out certain patterns, try to reduce the 3D deformations into 2D. Then blow up and stitch them together. Then stretch and plaster. Then formworks off. Then Vaseline and concrete. So, and families of those things. These are models. There's a moment when we make those figures. It's somehow we felt that we are designing something because suddenly you see people, but then also very attempting to also make concrete figures of the people from that model language because it deforms so much into minimum surface. Then we start wondering, well, is the human body made from minimum surface, or maybe we are only exist because of the excess of surface? It's quite difficult question to answer, to rationalize why minimum surface in the first place, or even definition of it. Anyway, I skipped that argument, but these are kind of from diaper development into this time, maybe instead of those open forms in downstairs, this time we try to enclose it and just twisting so that there's about inside to the outside, and same component A and B, but translated into 3-way directions, not only 8 planes. So means each piece demand another 2 pieces to join up. then also one paste the other, which twist inside, transform into outer skin. So these are model, directly we measure those models, blow up, make a full-scale jig, and start replacing by actual pieces. These are joint, and then fabric. So these are drawings done by Mustafa from DLL. It took much longer than the time we spent for bending pipes and making these pieces, actually. But then again, if these are drawn very quickly, then we may spend more time making it as well. So anyway, so these are another process. Assemble those 6 pieces and plastering it. And stretch the canvas, pasting concrete, 2 layers with pigments, red pigments and black pigment. And plaster formwork is being off. Those are 6 pieces. Then we call it furniture, how they can be assembled, joined up together into forms. So these are from the exhibition. Then towards later part of this fabrication, when we about to finish casting, then we received a phone call from Alan saying that, well, there is actually a fabricator who is interested to produce. Then because it's very, very last minute, so we weren't very sure about how much can we push it, but somehow Alan seems very keen to do it, guessing from his tone of voice, because he never say, well, if you like it, but somehow, so then he's very, very clever, because he said, well, there's only time you can meet those fabricators might be next Tuesday. So that's the day, actually day before Rubens took off to Brazil, and I was planning to travel further to Japan for after 3 days later. So, but anyway, we somehow convinced ourselves to go to city airport early in the morning, fly over to Munich, meet this fabricator. Then we discovered that they cannot do minimum surface. They only do ruled surface because of wire cutting things somehow. So on the way back from Munich on the same day, me and Rubens almost convincing ourselves that, well, there's no point of working with this fabricator because they're not specialized in 3D surface. But then look at Alan again. He seems a bit sad that we are not. So, so in a way, then we thought maybe it might be quite interesting challenge. So that's the point of kind of contact with external exterior work. So in a way, next 3 days, I have to make another model, adapting into fabrication technique they have. But at the same time, my computer broke down because I'm renewing it. So I cannot draw anything in 3D. Then Max, who's studied with George's unit, he seems to be very good with mathematical description of surface. So we convinced himself to come back again to work on this drawing. So in a way, then by the time I'm traveling off to Japan, we end up meeting on the Paddington station in the cafe and show the models and talking about how to communicate with fabricators. So that's the point. I think probably digital networks begin to work in different ways. We communicate in internet, sending information, me being in Tokyo, Rubens in Brazil, and Max in London, and fabricators in Munich. Then I don't have any 3D digital drawings, so Max has to translate. So this is one ruled surface model, simply bending paper. Then second model, there's a joint, and the simplified, so this time is only have 1, 2, 3, 4, 5. No, actually 6 pieces. Yeah, but a kind of comparison to previous piece I showed, it is not the minimum surface, it's ruled geometry. So their kind of solution to the detail is quite different. And the geometry, and these are hand drawings, the max translated into 3D models, different variations. Yeah. So breaking down into combination of the curved cones and the triangulations. Somehow that this is a piece. Then I think we realized that maybe different way of fabrication as an attitude, because previous sequence of fabrications, we do research by ourselves being isolated in a forest in Hook Park. And we actually research by borrowing some principle from fabrications and technique and bring into ourselves, our hands, refining another tools, redescribe those basic principles of technology. But in this time, it's quite different. There is a set of criteria and tools they already have in manufacturers. Then we have to work with it. So I think in terms of attitude for fabrications, or what argument shall we make as an architect or designer to what could be the motivation, could be quite an interesting trajectory, I think we would have. So I think I would like to end this with this diagrams and image. There's a book called Evolution of Technology. It's published in Cambridge. I think normally what we see as those tree diagrams shows how idea branching out. But on the other hand, if they have a very specific engineering criteria, the aim is very clear, but how their diverse set of relationships between ideas and inventions and techniques and tools can be overlapping one from another. But I think what we would like to leave as a question is, in terms of design practice, our aim cannot be so clear as the diagrams. For instance, end of those branch, things are overlap, coming back, reinvent itself, revisited like a David piece, it's become something else. But also, one image I thought quite interesting is this illustration from the same book. When two different principles collide, often makes most useless objects like bicycle adapted to staircase, which actually makes sense as an invention, but in fact it's kind of end of the design, I suppose. So I don't go back to this tree diagram. Are we seeing those bicycle as the end of those branch, which expecting to grow much further, or maybe actually branches cross, and what sort of geometry or form of technical representations be able to reflect what industry and materials and technique we would have as available materials today we can practice. Okay, thank you very much.